I just want to take a few minutes here to talk a little bit about negative exponents and how to simplify an expression with different kinds of negative exponents. If you have x to some power, and we're going to call that power negative a, that's an okay base in power to have, but simplified form in this module would require we write it with a positive exponent. So when you see something like x to the power of negative a, we know we can rewrite it as 1 divided by x to the power of a. So the way I like to explain this, and I say x to the power of negative a, is in a bad place. So what we need to do is pack up that negative exponent and we need to move it to its alternate position. So it technically is starting in a numerator position, so to make that power positive, we're going to put it into the denominator of an expression. So if I had a different example, let's say we had x to the power of negative 3 divided by y to the power of negative 2. When I look at these two terms, I can't put the x's and y's together because the bases are different, but I'm going to highlight the things that need to be moved. X to the power of negative 3 is in a bad position because it has a negative exponent. Y to the power of negative 2 is not simplified either, again, because it has a negative exponent. So if I were to rewrite this expression with positive powers instead, the y to the power of negative 2 is going to move upstairs and become y squared in the numerator. The x to the power of negative 3 is going to move downstairs and become x to the power of positive 3 in that denominator position. So if you take something that is written with a negative power and convert it to its positive power, it really just means moving that base to its alternate position. So what you need to be very careful of are examples like this. If I have negative 3 as an example, raised to the power of negative 2, I know that that negative power of negative 2 means that, yes, this is a valid number, but it's not really in simplified form, so we need to switch its position. This is in the numerator of a fraction, technically. If you want to imagine that this is over 1 right now, that makes it a little bit easier. That negative 3 to the power of negative 2 needs to switch into a denominator position. When it does that, the negative 3 out front stays as a negative 3. It's just the power that becomes positive. So this is going to be negative 3 written to the power of positive 2. Now we've packed up that negative 3 and we've moved it into the basement, but we need to show that that's sitting in the denominator of a fraction. So to make it look like proper fraction work, we're going to use a 1 as a placeholder in the numerator. From here, we could just evaluate and say that's really 1 divided by negative 3 times negative 3, which would be positive 9. Sometimes these expressions can become a little bit more complex. So if I had, let's say, 3x to the power of negative 2, y to the power of positive 3, all divided by 2x to the power of negative 4, y to the power of, let's say, negative 1. In this situation, once again, I want to highlight anything with a negative power. So x to the power of negative 2 is highlighted, x to the power of negative 4 is highlighted, and y to the power of negative 1 is highlighted. So those are 3 different bases that are sitting in bad positions. So what I like to do is just rewrite what I have in positive position so that I don't lose sight of them. The 3 in the numerator is perfectly happy. It doesn't have a negative power attached to it. Y to the power of positive 3 is also happy in the numerator, and 2 is happy in the denominator. So what's going to happen now is x to the power of negative 2 is going to shift into the denominator position and become x squared. X to the power of negative 4 is going to move upstairs and become x to the power of positive 4. And the y is going to move its position as well. So y to the power of negative 1 moves upstairs and becomes y to the power of positive 1. From here, we need to use our rules of simplifying to clean this up a little bit. So we have a 3 in the numerator and we have a 2 in the denominator. But if we combine your x's, we have x to the 4th in the numerator and we have x squared in the denominator. So if I cancel 2 of those x's, we're left with an x squared in the numerator. We've simplified those x's. For the y's now, I have y to the power of 3 multiplied by y to the power of 1. So we multiply those y's together and add those powers, which gives us y to the power of 4. So that's a quick recap of negative exponents, but sometimes when we put fractions or rational numbers in those exponent positions, it can be a little bit confusing. So we'll work through a few of those examples as well. Let's say now, as another example, we have something like 36 to the power of negative 1/2. We know if we see a fraction in that power position, it's really a root or radical in disguise, but the first problem we need to tackle is the fact that it's a negative power. So I'm going to pack this whole base and exponent up and move it across essentially an imaginary division line. So that's going to become part of the denominator of a fraction. And when it does that, it's going to be 36 to the power of positive 1/2. So when we shift into that denominator position, it becomes a positive power. Now, to make this look like a proper fraction, we'll use a 1 as a placeholder in that numerator. From here, we just want to remind you that this is really writing 1 over the square root of 36 to the power of 1. Remember, if you have a fraction as a power, the denominator is going to be the index of that radical, so it's the type of root we're dealing with, and the numerator of that little fraction becomes the power of the radicand. So if we were to evaluate this one more step, we have 1 divided by the square root of 36, which we know to be just 6. In other situations, you might see something like a big old fraction inside those brackets. So maybe we have 27 divided by 8, and that's raised to the power of negative 2/3. So once again, we go back to our exponent rules and we employ the power rule first. So when you see a power attached on the outside of a bracket like this, that power of negative 2/3 needs to apply itself to both the base in the numerator and the denominator. So I could write it as 27 to the power of negative 2/3 divided by 8 to the power of negative 2/3. So from here, we go back to our negative exponent rules and we say if you have a negative power, we need to switch its position to make it positive. So what we have in the numerator is going to move down into the basement. So we'll have 27 now to the power of positive 2/3. So the only thing that we change is that negative power to a positive power. And that 8 to the power of negative 2/3 is going to move upstairs, and it becomes 8 to the power of positive 2/3. Now, again, just a reminder that when you have a fraction like that in your power position, it really means it's a radical in disguise. So we've got the cubed root of 8 raised to the power of 2. And in the denominator, we have the cubed root of 27 to the power of 2. So from here, we just need to evaluate these radicals. So you could multiply this through and say 8 squared, for example, in the numerator is 64, and find the cubed root of 64. I evaluate this using a little bit of a shortcut. I'll take the cubed root of 8, find an answer, and then square it later. In the denominator, I find the cubed root of 27, again find an answer, and then square it afterwards. It helps to avoid using some really big numbers. So the cubed root of 8 is just 2. When I square that, ultimately I'm going to get a 4. In the denominator, the cubed root of 27 is just 3. And again, I'll square that eventually. So my final answer should be 4 divided by 9. We'll run through one more similar example. Let's say we have in brackets 49 divided by 25, all raised to the power of negative 1/2. Again, that power on the outside applies to everything inside those brackets. So this becomes 49 to the power of negative 1/2 divided by 25 to the power of negative 1/2. So we apply that power to both of those bases. From here, we see that both of those terms are in bad position. So we need to move that base of 49 and the base of 25. So when we do that, we get 25 to the power of positive 1/2 in the numerator and 49 to the power of positive 1/2 now in the denominator, because these two terms have essentially switched positions. So 25 to the power of 1/2 doesn't mean half of 25. It means the square root of 25 to the power of 1, or the square root of 25. In the denominator, similarly, we have the square root of 49 to the power of 1, or the square root of 49. So the square root of 25, we know it's perfect square, so the answer there is 5 in the numerator. The square root of 49 is just 7, because again, 49 is a perfect square. So hopefully this helps you identify what to do with negative powers, and really it's just a switching of their position and then evaluating them as roots or radicals.